Enzymes are going to be molecules that speed up chemical reactions. These enzymes, for the most part, are going to be proteins, but that is not 100% true. We will see in later chapters that we can have RNA molecules that function as enzymes as well. But for now, we are going to focus on these protein ones. So enzymes, they're speeding up reactions, making them to go faster. And the way that they're going to do this, their mode of action, is going to be to lower the activation energy. So in other words, they're going to lower that EA, or the hill that the reactants are going to have to climb on their way to the transition state. So looking at this reaction in front of us, if we just look at what we can already tell about this, this is going to be an exergonic reaction. And we know that it's exergonic because if we were to calculate the delta G, remember that the delta G is the amount of energy in the product minus the amount of energy in the reactant. And in this case, we can see that the product is going to have less energy than the reactant is going to have. So what that means is that overall, the delta G is definitely going to be negative. So another thing that means is that energy is going to be yielded in all of this. So we would actually see energy come out. And we could also say that this is going to be a spontaneous reaction. So all of those things would apply to an exergonic reaction such as we have here. Now, another thing that we can see in this diagram is we can get a look at the activation energy. And the activation energy is the distance from the reactant to the top of the hill. So it would be this space right here. So I'm going to call that the EA for the activation energy. And that really is going to determine how fast this reaction takes place. So the higher that activation energy is, the slower the reaction is going to be. Recall that at the top of that hill is going to be where our transition state is for the reactant. So up here would be the molecules in a transition state. That is a very unstable state, and that's why it requires there to be so much energy involved, because again, it does have a high potential energy. So if we talk now about our enzymes and what our enzymes are going to do in all of this, the enzymes are going to change that activation energy. So if I draw right on top of this, it's going to get the diagram a little bit messy. But if we start in the same place with our reactants, and now my hill is lower, okay, and I just changed the line. So now looking at the blue line, if we are to evaluate our activation energy, notice that in this example, the new activation energy is lower than it was previously. Okay, so since it's lower, it's a shorter hill, we're not going to have to absorb as much energy to actually get to the top of the hill. So we would expect that that's going to be a faster reaction if the activation energy is kind of the limiting thing here. So that's what an enzyme is going to do. An enzyme is going to lower the activation energy. So when we look at this blue line, the blue line is representing the reaction, and this is the same reaction with enzyme. So when the enzyme is present, we're going to have a lower activation energy, and that means that the overall reaction is going to be faster than what it was previously. Here we have just another look at this. As you can see in the first diagram where we're showing it in red, we have a higher activation energy. So we would have to get to the top of that hill, which again, at the top of the hill is where our transition state is going to be. And the transition state is a state when the reactants are going to have a higher potential energy. And so when we get to the top of the hill, then the rest of the reaction is going to proceed rather quickly. But it is that climbing to the top that might take us a little while. So it could take a while to absorb that energy in the form of heat from the surroundings. If you look at the second diagram, the one shown in green, we can see that our activation energy is much lower. So to climb this hill is going to be a lot easier than it was to climb the hill in the red diagram. That's the reaction with the enzyme being present. So since the enzyme is there, the reactant can get to that transition state quicker. And again, the rest of the reaction is rather fast anyway. So the reaction with enzyme is faster. And that reaction would, in this case, be the one shown in green. Now, if we talk just very briefly about what the enzyme is actually doing in all of this, the reactant is going to get converted to product during this whole overall reaction. And a lot of times we write the enzyme just right next to the arrow in this chemical reaction. And that's because the enzyme is not consumed. This is something that is reusable. We can think of the enzyme as just a helper in facilitating this whole reaction. So what the enzyme does is it is usually a rather large molecule, and it has a unique site on it, which I've drawn right here. And that unique site is called an active site. And that active site is going to be where the reactant, if I just draw my reactant, in this case, I'm going to draw it as green, that reactant is going to fit right into that active site. So when it fits in the active site like that, we're going to call this molecule the substrate. So the active site is designed to accommodate a specific substrate. This is not a one-size-fits-all. It's a very tight fit, so it's like a lock and key would be. And once the substrate is in that active site, that is when the enzyme is going to lower the activation energy. There's a number of ways that it can do that. It may simply, if we talk about the things that the enzyme is doing, it may be simply providing a microenvironment that is ideal for the substrate to get to that transition state. The enzyme may be helping to strain some bonds, would be another possibility. In some cases, it actually binds covalently to the substrate. Now, if this is the case, then those bonds do later get broken because we do want to have the enzyme unchanged in all of this. So remember, the enzyme is just helping or facilitating this process along. So the enzyme is going to bind the substrate in the active site. At that moment, the activation energy is going to be lowered, and then it's really just a split second later that we're going to have the product generated in this process.